Problem set 83. Up to this point, you have been integrating odd powers of trig functions. How do you do this? Split. Then what? So what is sine squared? 1 minus cosine squared. Then you multiply out. Make sure you're using equal signs often and regularly. What's the integral of sine? Almost. Negative cosine, right? Because when you take the derivative of cosine, you get that. What's the derivative of this? Well, you would do u substitution. This is u squared. This minus du. So, what is this going to be? Plus.
What's that? U squared.
Well, the integral of u squared is u.
The u third over 3.
Yep. And u is cosine, so it'd be cosine cubed over 3. So, that is the review. You viewed that once. Now we viewed it again. So, let's go a little bit deeper now. We are going to now integrate even powers. How do you do that? Well, again, it's going to be one of our identities. Which identity? Always cosine. Remember that we have an identity for cosine of 2x. It is 1 minus 2 sine squared, or 2 cosine squared minus 1. So if I solve these for sine squared and cosine squared, which is what I'll need for these problems, I get sine squared of x is cosine of 2x. Sorry, 1 minus cosine of 2x over 2. And I get that cosine squared of x is cosine 2x minus 1 over 2. You will never use sine of 2x. Always cosine. So, always cosine. When you have a square, you're always going to use one of these two in order to get rid of it. So, what am I going to do? Well, I'm going to substitute in. I have cosine squared, so I'm going to use this substitution. So this is the integral of cosine of 2x over 2 minus 1 over 2. Just splitting this up. Can we integrate cosine of 2x over 2? Yeah, sure. What is u? We'll make u 2x, which means du is 2 dx, right? So I'm going to have to divide by 2 again here. So this guy is 1/4 cosine. Nope, the integral of cosine is sine. What's the integral of 1/2? 1/2 x plus c. Now, we can always check this. If I take the derivative of sine, I get cosine, and then I will have a 2 in front, so 2/4 is 1/2. Okay? But the real difficulty comes in at this point. What happens if we have a higher even power? Well, we're going to try the same thing again. So we have sine squared is 1 minus cosine of 2x over 2, right? But we have that squared, because this is sine squared squared. Not fun. So I have to square this. What is this going to be? This is going to be 1/4 minus cosine of 2x Is that right? Yep. Plus cosine of 2x squared over 4. Gross? Very. Can I integrate this? Can I integrate this? We already did it right there. It's 1/4 sine. Can we integrate this? So now we have cosine squared. So now we have to do another substitution. So I'm going to bring the 1/4 out because I don't want to deal with that. So now I have the integral. But remember, this is cosine of 2x squared. So now, instead of every time I see x here, I'm going to put in 2x. So what's this going to become?
4x.
So let's keep integrating. 1/4 x minus 1/4 sine of 2x plus, now this is going to be sine of 4x over 4. So it's going to be over 8 times 1/4 still, minus 1/2 x. Is that your answer? No, because you have 1/4 x and you have 1/8 x. What's 1/4 minus 1/8? Like, I get 1/8, but
Don't want to use my calculator.
I messed up somewhere. I don't know where. I have no clue. So we have 1/4 minus cosine of 2x over 2 plus 1/4 cosine squared of 2x. And we get that out. So there's a 1/4 there. Somehow they ended up with 3/8 x.
I was gonna say that.
Oh, you were? How do they get 3/4? You have 1/4 minus 1/8. 1/4 plus 1/8 is 3/4. Oh. This one's plus. Ah. Okay. Now I'm happy with that. 3/8 x minus 1/4 sine 2x plus 1/32 sine 4x plus c. Good. Woohoo! That's your lesson. So use those identities, use the correct identities, and they will help.